Hi, this is Team 6171, FRC Chain Reaction Robotics, and this is our video about how to get started from you've just joined your software team and you need to make a drivetrain. So here's how to program a drivetrain. First of all, you may be asking, what is a drivetrain? And that's the entire system of motors, wheels, and other things that makes a robot move. And it's the most important part of your robot, because without a drivetrain, you really can't do anything else in a match. For this tutorial, you're going to need a built drivetrain already, so we're not going to cover how to build a drivetrain or how to wire up a drivetrain in this tutorial. So you're going to need the mechanical and electrical aspects of your drivetrain completed. So if you're able to turn on the robot and connect to it, you should be good. You're going to need a computer, preferably running Windows, but any operating system should work. You're going to need some programming experience, preferably Java. We're going to be using Java all year in robotics. Um, so if you have Java experience from, say, computer science classes, that's going to be perfect. But even if you don't, maybe if you're coming from like JavaScript or Python or even Scratch, you should be fine. If you're coming from a different language, I would recommend these Java beginner tutorials at w3schools.com/Java. Where you can get familiar with class structure and data types in Java and all these kinds of statements like FL statements and switch cases, because we're going to be using those quite a bit. But mainly you're going to want to get familiar with object-oriented programming because that is usually a huge roadblock for new members. You need to install these. We're going to have links in the description of this video, but first you'll need to install WPILib VS Code, which is a source code editor that you can use for different applications, but the WPILib version actually contains tools for FRC. You're also going to want to install the FRC Game Tools, which contains the driver station application. This will be used to connect to the robot and control it. You're also going to want to install extensions on your VS Code. So once you have a successful install, you can go to the extensions window, which I'll show you later, and install extensions like LiveShare, GitLens, GitHistory, etc. Again, we'll include all of this in the description. So what is the command-based framework? So we're going to use this framework to provide structure for our robot code by organizing it into two different parts: subsystems and commands. These organizational units are going to help keep our code easy to read and write. This link below has the official documentation at WPILib, or WPILib, with command-based and a basic explanation. However, we summarize it because it's very long in this video. First of all, a subsystem is a code for a collection of robot hardware that operates together as a unit. So as you'll see in the picture down below, these are some examples of subsystems. So your drivetrain is a subsystem, along with, say, if you have a robot arm, that's going to be a subsystem. If you have something that shoots balls, that's another subsystem. If you have a little elevator or a gripper, those are also both subsystems. So they encapsulate lower-level robot hardware, such as motors and actuators and sensors, and they put it into one big organizational unit called a subsystem. A command is a specific action that takes place within a subsystem, like making the shooter spin up to a certain power or to make the drivetrain move forward. So here are some examples, like a drive to goal command or a bring the elevator to a high position command. So, however, I will note that commands are similar to methods or functions in Java, but they are not the same. Commands are actually a class, and we'll show you how to write commands later. Commands are run by the command scheduler, which is a class that manages ongoing commands and memory usage, so they get automatically scheduled. Multiple commands can be running at the same time, and you can even have command groups where you can have them run at the same time in a parallel command group, or one after another with a sequential command group. The command-based library and framework provides us several types of command groups to use, but custom ones can be written too. So let's get to coding. So first we're going to write a drivetrain class, and I'm going to open up VS Code. So once you have it installed, it should look like this, 2021 WPILib VS Code. So once you open that up, it may look like this. So you're going to do the Control-Shift-P. That is a very frequent command. So with this, you can type in things into the search bar and it will return different functions that VS Code has for you. So we're going to create a new command-based project. So I'm going to search for the word create and then click on or hit enter on WPILib create new project, which will bring me to this screen. So if you click on template and select language Java, then you'll be presented with these different options, or maybe less, but all you have to do is select command robot. Do not select old. You have to select the new command robot style. So I'm just going to select a project folder on my desktop. You can really put it anywhere, unless you're using GitHub, for which we'll talk about it later. So I'm going to put it in my robotics folder. I'm going to call it 0 to Vroom. I'm going to you can leave this checked or unchecked. It's fine either way. I'm going to enter our team number, 6171, and click check and generate project. I'm going to open it in the current window. So if you have any questions by this point, I would rewind the video and review the slides or read the documentation, because we're about to get coding. So you can let this terminal task execute on its own. What it's doing right now is compiling the code, even though we haven't written anything, just to ensure that everything is okay. So organizationally, your code is going to be in this SRC or source folder. So you have to go to source/main/Java, and then inside the Java folders, there's going to be FRC and then robot. This is where your main robot code is going to be. So in here, we have a commands folder and a subsystems folder. They've given us an example command and an example subsystem, which you can read on your own time, but we're going to focus on how to make a drivetrain class right now. So I'm going to click subsystems, I'm going to right click it and hit new file. Then I'm going to call it, having a minute there. So here's drivetrain.java. And that will create a new class. VS Code may auto-populate it with this text. However, you can type this manually as well. You're going to want to say that the drivetrain class extends subsystem base. Now, if you're familiar with inheritance, you may understand what this is doing. The subsystem base class is given within WPILib, and once you hit enter, it will auto-import this. If it doesn't, you can always right-click it and hit there should be an option to quick fix it to make the import automatically happen. But if you're not familiar with the inheritance, basically this is just saying that the drivetrain is a subsystem base or a subsystem. So now we're going to write the constructor, public drivetrain. Actually, the drivetrain class doesn't have a constructor. I'm wrong. You're also going to want to download any of the frameworks for the motor controllers you're going to use. So let me go back to the slides. So there are different kinds of motors, such as the Talon FX, Talon SRX, and CAN SparkMax. These are different motor controllers, and they all have different classes in code. We're going to be using CAN SparkMax for this video because that's what we have at Chain Reaction, but you can use whatever you want, and the code will mostly be similar. So I'm going to create 4 different CAN SparkMax objects because we have 4 in the drivetrain. So CAN SparkMax, first, you're going to have to add it to your project. So Control-Shift-P again, and then hit Manage Vendor Libraries. So you can search Manage Vendor Libraries and it'll show up. Then hit Install Offline and select Rev Robotics. To do this, for it to show up, you're going to need to look up the Rev Robotics SparkMax installer, which will install this package for you, and you can look up how to do that. So I'm going to import it, and then it should let me type CAN SparkMax. There we go, CAN SparkMax. And then I'm going to say LF for left front equals new CAN SparkMax. And then we need to pass in a ID number. So this would be the CAN ID device number. You can ask your electrical team for what each CAN device ID is, but we're not going to explain the CAN system in this video. I'm just going to leave it at 0 for now, so you can edit it later. It's also recommended to use constants like that in the constants.java file, where you would obviously store constants. So you can make a public static final int and set it equal to whatever the ID is. For the type, you're going to want to type motor type dot k brushless. This will indicate that it is a brushless motor like the Robotics Neo. That's what we use in our drivetrains, but you can really use anything again. So I just copied this line and pasted it 4 times, but I'm going to change the words here. So left front, left back, and right back. I'm also going to change the motor IDs to be something random. Again, this will have to be changed according to your robot. Now, you have to make a... Oops, where is it going? There. You have to make a speed controller group as well. Or, sorry, a differential drive object. So the differential drive object takes care of the logic behind the driving, so you don't have to do any of the math. So that would be created with a differential drive. Again, I'm using tab completion here, so I type out part of the word and then I hit the tab key on my keyboard and it automatically imports it and completes my sentence. So, or word in this case. Differential drive, drivetrain, or I normally type DT for drivetrain, equals new differential drive. And then it's looking for only 2 motors. But you're like, wait, we put 4 motors here, and we have 4 motors in the drivetrain. I want to use all 4. How can I do that? The trick is to use speed controller groups. So you can type new speed controller group, and then pass in your LF and your LB, which are both on the same side. They're both on the left side, so they should both go at the same speed. I'm going to do the same thing for the right side. New speed controller group RF, comma, RB. Semicolon, and it should ask me for an import. Okay, it already imported it. So that's that. And pro tip, you can split this into multiple lines. That makes your code look a lot neater. So I normally do this or something like this, and that usually helps viewers. So that's your basic objects. So now we need to create a drive method. Public void drive. I'm not going to give it any parameters yet, but the differential drive class takes care of the driving logic for us. So I'm going to hit dt dot arcade drive. Arcade drive will take in 2 joystick inputs from, say, an Xbox controller that you can connect to the driver station. So if you have 2 joysticks, one would be for the forward-backward speed, and the other would be for the rotation axis. So that's what the X speed and Z rotation parameters are. This is the equivalent of the throttle in your car. So that would be X speed, how much power to go forward or backward with. And Z rotation would be the equivalent of the steering wheel. So for X speed, I'm just going to make 2 parameters here, and I'll show you how to use it later. Double X speed, double Z rotation. So now you should have no errors. To make sure that your code is all good, hit Control-Shift-P, and then type build robot code. This will just compile your code using the WPILib compiler, and it'll make sure that your code has no errors. I know it says problems 1 here, where it says there is an unused parameter, but you can ignore that for the most part. So we're just going to wait for this to build for a sec. After this, we're going to go into the robot container class, where we're actually going to use the Xbox controller to control the robot. Hey, it built successfully. If your code didn't build successfully, look for compilation errors. You can go to this Problems tab and see what's wrong with your code. Again, we'll put a GitHub link in the description that will contain our code in case you want to compile that instead. So after that, navigate to robotcontainer.java. This file is where you're going to put most of the robot's declaration. So you're going to put subsystems and commands here, as they've shown in this example. I'm going to leave these 2 here and just create a drivetrain. So drivetrain. And again, look, I don't need to remember about the imports. I just type drivetrain and hit tab, and it will automatically import the drivetrain subsystem for me. So drivetrain dt equals new drivetrain will take care of that for us. So, and if you're familiar with Java, you will recognize that this is pretty bad syntax. Normally you would do drivetrain dt here, and then say dt equals new drivetrain in the constructor here. But we've found that it really doesn't affect your code. So for being concise's sake, we normally just keep it here, and it works fine. So in this constructor, this is where you're going to link the Xbox controller with the drivetrain. So first, you're going to define an Xbox controller object, again, with the auto import. I'm going to call it driver controller equals new Xbox controller. It's going to take an end port parameter. This port would be the USB port that is plugged into. So I'm just going to say 0 to indicate that it's the first, because it's indexed at 0, port that it would be plugged into. Next, I'm going to do, here's the huge important part. So I'm going to zoom in a bit and close this. dt.setDefault command. This will schedule a command automatically whenever there is no other command scheduled on the drivetrain. So if you don't tell the drivetrain to do any autonomous tasks or any other commands, it will run this command by default. So in here, we're going to pass a new run command. Run commands will run a method for an unspecified amount of time. So in here, we're going to pass a method reference, which is just a reference to a method rather than a call to a method, and the requirements for this command. Every command requires the subsystem that it is called on. So in this case, the command would require just the drivetrain. But you can pass in, say if there was a shooter, you could also pass in the shooter. So here is where I'm going to put a lambda expression, which you can look up a lambda expression. It basically looks like this. And instead of the word expression, we're just going to have a line of code. So dt.drive, and then in x speed, x rotation, z rotation, that's where we're going to call the driver controller. So in x speed, we're going to say driver controller dot get, that would be the get y, hand.k left. So this would get the y-axis or the vertical axis of the left hand. I will say, on an Xbox controller, the y-axis is inverted, so you have to put a negative sign whenever you request it. So z rotation, we're just going to do driver controller dot get get x, and then hand.k right. That way it's split hand control. So we're using the y-axis of the left hand and the x-axis of the right hand to go into the throttle and the steering, respectively. Remember, no semicolon here. That's just the error that it was giving me, and we got to make a quick import. So you can right-click something or hover over it, and it'll say quick fix, where you can import hand or whatever you need to import and fix. So with this, you should be able to deploy the code. So if you type deploy, it'll give you the option to deploy robot code. That requires you to be connected to the robot, which I'm not right now, so I'm just going to build it to confirm that it works. Deploying, on the other hand, would build your robot code and send it to the robot. So right now, I'm just compiling on my computer. There, it worked, so we're good. So with that, you're going to follow these instructions to connect to the robot and build and deploy code. You're going to hit the enable button, and if you plugged in an Xbox controller, you should be good to move the robot around. Now, you can read this slide by pausing or viewing the slides in the description of this video. Oh, and that's it. Thanks for watching.